These past 2 weeks, we continued experimenting with cyclic voltammetry. We noticed that the Pine Wave Now kit provided us with two different blue electrodes, one with a 2 mm diameter and one with a 5 mm diameter. This CV of 10 millimolar potassium ferricyanide and 1 molar potassium nitrate is using a 5 mm diameter electrode. Notice the graph has a peak height of approximately 320 microamps, while this CV, using a 2 mm diameter electrode, has a peak height of about 35 microamps, about 1/10 the height of the 5 mm electrode. We decided to perform CV on children's Tylenol to experiment with how various concentrations of acetaminophenol affect the final CV graph. Here we have a saline solution used to wash contact lenses, children's Tylenol, a concentrated stock solution of the Tylenol dissolved in the saline buffer, and our two running solutions, one using 2 millimolar and the other using 4 millimolar acetaminophenol. This CV shows the 4 millimolar Tylenol solution with a lower peak height of 23 microamps. This CV shows the 2 millimolar Tylenol solution which has a lower peak height at 2 microamps. This experiment shows how the peak heights are not directly proportional to the analyte concentration. If it were proportional, the 2 millimolar Tylenol solution would have half the peak height of the 4 millimolar Tylenol solution. Since our future plan is to layer the electrode with polyethylene amine, we begin experimenting with the PEI. Here we have branched PEI and linear PEI. We created a stock solution of 2% linear PEI. Here we are using a micropipette to dispense 50 microliters of our 2% linear PEI solution onto a glass microscope slide to test how the solution will spread out over a flat surface before we use an electrode. We then use nitrogen to evaporate the solvent, so we will be left with only the layer of PEI on the glass slide. The glass slide is then weighed to determine the mass of the PEI layer. According to the scale, the PEI layer weighs approximately 1 milligram. However, this mass could be due to a number of other variables. It may be that the PEI layer does not weigh enough to be detected by the scale. This is the CV of the 10 millimolar ferrocyanide solution using a 2 mm diameter electrode with a layer of 2% linear PEI after it was evaporated with nitrogen. Evidently, the shape of the graph near the upper potential changed, as well as the electrode current range, which seemed to increase with the layer of PEI. This week and continuing on to next week, we are fluorescently labeling BSA molecules. We plan on using the BSA as a temporary substitute for the phage so we can experiment with how it will bind to the PEI and change the cyclic voltammogram. In a few weeks, we will inoculate bacteria with virus provided by the chemistry department from UCI to produce the phage that we will attach to the PEI layer. The PEI will act as a sort of double-sided tape, connecting the phage to the electrode through a magnetic attraction. Once we have this layer attached, we can begin experimenting with cyclic voltammetry and how the phage will act to detect bacteria, specifically E. coli.